Hello friends, welcome to the data structure tutorial. In this video, we will be discussing about stack. Stack is one of the important concept in the data structure. And as I have mentioned that stack is a linear data structure. It means that whatever data you will be storing into the stack, that will be in the linear way, that is one after another. And if you look at the second point, it is showing that the working principle is last in first out. Now what it means that? So I have written some real-time examples here that CD or the DVD stand and the stack of books in the bookshop. So let us take an example of this DVD stand. Suppose we have a DVD stand and we want to keep our DVDs into this stand. So when you put your first DVD, this is your first DVD, and now you want to keep your second DVD, so you have to use only this end. You cannot keep the second DVD through this end because that is not allowed, which is fixed. So you have only one option to insert your second DVD. So you will insert from this end, and this will be your second DVD. Same way, if you have inserted the third DVD, so that will be above the second DVD. And now if you want to access the DVDs, even if you want to access the first DVD, you do not have a choice to directly go to the first DVD because the second end is fixed. So to reach to the first DVD, you have to remove this third DVD first, then second DVD, and then only you can remove the first DVD. So even if you have inserted the first DVD at the very beginning, you are not able to access that. And even if your third DVD is inserted at the last moment, but you can accessing the information that is third DVD at the very beginning. So that is the meaning of last in. The third DVD is inserted last one and we are keeping it out at the very first time. So this is the concept of last in first out. And whatever data we will be storing into the stack, like in this example we are putting the DVDs onto this stack. So this insertion of the DVDs is this operation is called as push. And if you are removing the DVDs, then or you are removing the data from the stack, then that operation is called as pop operation. And the DVD which will be lying at the top of your stack, that end is called as the top of the stack, and only through this end you are performing the operation, so that end is also called as top end. So let us take a example related to the stack using array. So as we know that array is a linear data structure which will storing the data of similar type in a sequential manner. So let us assume that this is our array. We'll name this array as a stack, and to this stack we want to store our element, so we'll keep the indexing. For example, the indexes are like this is 0, this is first, and this is second index. And now you want to insert the element into this. So what we'll do, by the definition, the operation on the stack are done through only one end, and that end is called as top. So we are not able to perform operation on the both end, that will be performed only through one end, and we are assuming that this end. Now there is a no element present in the stack, so initially we'll keep one variable. We'll keep one variable. Suppose initially we have a index -1, and we'll take one variable whose name is top. Now this top variable is indicating your current index of the element, and this entire diagram is representing your stack. Okay. Now if we asked user to insert the element, that operation is called as push. So suppose user want to push an element A. So what will happen? Top will be pointing to this location. This will be your new top, and at this top means inside this stack, at this top, that is 0th position, you will be inserting your first element. Now again, if you user ask you to push the another element, that is B, so where it will be stored? It will be stored on A and B. This will be 0, 1, 2. And who is the top now? The Bth element, which is representing the index 1. Now if user is asking you to push the another element, suppose C, and you have entered that element at A, B, C. Now who is at the top? C is at the top. What is the index number? The index number is 2. And let us assume that you have a stack of size 3. So how many elements you can store? Only 3 elements you can store, and we have reached to that position. And now if user is asking you to store another element, for example, user want to push another element, that is D. So we have already occupied all the locations of 3 positions into the stack, and we are allowed only to use the maximum of 3 elements, and the top of your stack is representing the second index. So this will not allowed. So what it means, your stack is full. Your stack is full. So here we have written one point, stack is full when your top is equals to size minus 1. So what is the size here? Your size is equals to 3 for this example, and if you are writing size minus 1 is equals to 2, and where is your top? It at second location. It means that if your size minus 1 value is equals to the top, if this case is there, it means that your stack is full, right? And now if you want to write an algorithm for this, so simply you can write algorithm. So let us create one function. For example, we have a function push. We are assuming that we'll get an data. What kind of data you want, you can get it. And you need to check before insertion whether the location is available or not, whether we have a place to add the data or not. So how will you check that? So you will check the condition if the position of your top is equals to size minus 1, then your stack is full. Else, if it is not the case, then you will increment the position of top by 1. So which we have already done here. Initially it is at the minus 1. Before inserting the new element, we have increased the position of top by 1. So we have incremented it. So top from minus 1 it becomes 0, and then at the top of the stack you will be inserting your data. And this is how you will push your element onto the stack. Now if we want to delete the data, let us take same example. We have a stack and we have the elements like we have already inserted A, B, C, indexes are 0, 1, 2. This is your top, and we want to remove the element. Okay, so whenever you remove the element, so initially you will call that operation as a pop. So you will write only call the pop function. So what it will do, it will remove the element which is at the top. So who is at the top? C. So it will gives you output as a C. Then top will be automatically going to the next element, that is B. So the new index will be like this. It is 0, 1. The top is at 1 now. This will be your new top because you have deleted the element. Then again user is calling pop. So it will return the variable B. So automatically if B is removed, the new top will be at 0th index, which is pointing to A. Suppose user is again calling a pop, so it will pop the element A, and the new element is the new position of the top will be at minus 1. Now if user is again calling pop function, what will happen? There is no element to pop from the stack. Then it will tell us that the stack is empty. So what is the condition to check whether the stack is empty? That whenever the top is equals to minus 1, then it means that there is no element to pop from the stack. This is the condition. Now let us write the algorithm for the operation pop to remove the element. So I'll create one function pop, and here we need to check that whether elements are available or not. So you will write if top is equals to -1, then your stack is empty, empty, else you have to remove the element from where? From the top of the stack, and you will store in some variable, let's say x, and once you remove the element, your top is automatically going to the next location, so your top will be decremented by 1. So initially top is at second location. When you remove this element C, so next top will be B. So that is what we have done. The position of the top is decremented by 1. So this is an algorithm for the pop function on the stack. Now let us try to implement this in Java. So I have created one folder, DS tutorial, and here I'll be creating a new file. I'll name that file as suppose demo stack.java. And here we'll write the logic related to the operations on stack. So I'll start from the scratch. So I'll create one class, demo stack, and it will contain your main method, that is public static void main with string arguments. And when you are performing operation on the stack, so we'll create a separate class above this. So I'll create the class called stack operations, and inside this class I'll be writing two methods, that is void push, and I'll create another function, that is void pop, and inside this we'll be writing our logic. So push function is getting one value, so we'll creating an operation on integer data, so I'll create an integer data. Okay, then we need some declarations here, so we need a stack, so we are performing operations on the integer stack considering. So let us declare an integer stack, new integer, and size you can mention like integer size is equals to suppose 5 elements, and here I'll mention the size. So we have declared the stack, then we need some variable like integer top is equals to, initially it will be at -1. We need some variable like data. Okay. So user will send one data that will be copied into this data. Then we have to check whether whether there is a place available into the stack or not. So how will you check it? We have written in the algorithm that if top is equals to size -1, then we do not have any space, so I'll simply write system.out.println that stack is empty, and we'll go back. Else if it is not the case, then whatever data you have received, you have to push it onto the top of the stack, but before that you need to increment the position of top by 1. Then on the top of the stack you will copy your data, that's it. And if you want to display one message, so simply you can display one message that data pushed, and what data you have pushed, just display that data, that this data which we have just pushed. Okay, so we have written just an algorithm of push. Now let us write an algorithm for the pop. So to perform the pop, the condition we have to check whether there is a data to delete or not. If there is a no data, how will you know that? So when top is equals to -1 means there is a no data. So you will simply print one message that stack is empty. Sorry, I have written a wrong message there. It should be stack full. When the top is equals to size -1, it should be full. When top is equals to -1, then it should be empty. Else, and if it is empty, we'll return. And here you will write you will copy the data from where? From the top of the stack, and you will decrement the position of top by 1, right? And you will display one message that what data you have popped. So I'll write data popped and we'll display that data. That's it. And once you've done this, you want to display the entire stack. So here I'll create another function, that is void display, and it will check whether there are some elements to display or not. So again we have to check the same condition, that is whether the stack is empty or not. If there is empty, then how can we display anything? Else if it is not the case, then we have to display all the elements from top to the bottom of the stack. So I'll create one for loop. I'll declare one variable integer I is equals to, which will be starting from the top, which will always remain greater than or equals to 0, and will be decrementing I by 1, and every time I'll print the stack ith element, because it will be starting from top, then top minus 1, top minus 2, till top will reach to the 0. So it will display all the elements. Now let us call it from the main function. So everything we have written in the class called stack operations. So we'll create an object, suppose op is equals to new stack operations, and we'll call it manually, that is op dot, let us call push. So I'm pushing the element, suppose randomly 34, then I'll push few more elements to check. Now I have pushed 34, then I'll push some random 44, then 23, 63 and 12. So we have pushed total 5 elements, and let us call the display, that is op dot display. So we are expecting that what was the last element we have inserted, it's a 12. So it should be on the top of the stack. So let us run your code. So here you have to compile your code. So I am using a manual way, Java C. You have to write your file name, that is stack.java, and then compile your, after compilation run your class, that is demo stack. Hit the enter, and you can see that we are getting the messages that initially it is push 34, which is at the bottom, 44, 23, 63, 20, 12, and if you display it, 12 is at the top of the stack. Now we want to delete something. So whether it is performing correctly or not, so we have displayed total inserted 5 elements. So if I add one more element, so if I add one more element, what will happen? Suppose I have added the 88, and if you run this code, even if you have not displayed it, so let us compile it again and run it. So you can see that after the last element which you have inserted is 12, we displayed the list, but when you trying to insert the element 88, it is displaying you the message push, sorry, full. Why? Because the size of the stack which you have mentioned is 5, and you are trying to add the 6th element. So our algorithm is working fine. Now let us check for pop. So op dot pop. So you pop the first element. So who is at the top of the stack? It is 12. So it should be removed. Then again I'll call pop. Sorry, op dot pop. Then the next element 63 should be removed. Okay, and then we'll try to display that op dot display. So look, we have inserted last element, that is 12. Then we try to insert 88, so we should get a message like it is full. Then it should remove the two elements, 12 first and 63 later. And then who is the next top? The 23 is should be at the top of our stack. So let us compile it, and if you run it, you can see that we have pushed these many elements. We are trying to push 88, but it is not inserted because the size is full and we are not able to insert the element. You pop 12, 63, who is the next top? 23. So okay, it is correctly defined. So this is how you can implement the stack, and you can use as per your requirement. So there are several problems like reversing a string, conversion of decimal to binary, the evaluation of postfix expression. You can use the stack. So try this much, and even if you want to make this automate, so you with the help of switch case you can do that. So I hope all of you have understood this. We'll see you in the next video.